everybody, this is Beatrice Makenzie, and today we'll be doing 3 topics. Plate tectonics, continental drift, and seafloor spreading. But before we do anything about that, I would like to introduce a special guest. This, everybody, is my friend Mia, and she is going to help us learn about plate tectonics and help me with the visuals. The first plate boundary that we're going to talk about is convergent. Convergent boundaries push together, like these 2 rocks, they push together. They form mountains, volcanoes, islands, and deep ocean trenches. And they cause earthquakes when they push together. Okay? Second plate boundary is divergent. That means they pull apart from each other. Like this. They form mid-ocean ridges and rift zones, and they cause seafloor spreading. The last, and I don't think final one, is transformant. That means slide past, like these 2 rocks there. Mia, why'd you drop your rock? Here, have your rock back. See, they slide past each other. And they cause earthquakes. Our next section is continental drift, a theory that was formed by Alfred Wegener that the continents used to be one big supercontinent called Pangea, or as he said, Urkontinent. It's German. And we will have a demonstration of what the continents did. Alfred Wegener had 4 pieces of evidence to support continental drift. Fossil evidence, landform and rock formation evidence, glacial evidence, and continental fit evidence. Fossil evidence is where Mesosaurus fossils, which is a freshwater dinosaur, was found on both the tip of Africa and the tip of South America, as shown on the thing right there. The pipe cleaners that are on the rock represent where Mesosaurus fossils were found. The smaller rock represents Africa, and the bigger rock represents South America. As you can see, the pipe cleaner on South America matches up, if you put them together, with the pipe cleaner on Africa. The second part of fossil evidence is palm tree fossils were found in Alaska, a cold state where palm trees should never have been, as shown in the demonstration here. The pipe cleaners, the fuzzy green pipe cleaner represents the palm tree fossils and where they were found, and the small rock represents Alaska. The next piece of it, wait, you would like to do this one, Mia? Yes, I would. The next piece of evidence is landform and rock formations, meaning mountains, valleys, rivers, plateaus, etc. look like they match up on different continents. Like as seen in the diagram, on the diagram in front of us. Are you going to point to it? Sure. Okay, and the second And the second part to this piece of evidence is rock formation / rock layers, meaning scientists have found a rock on one continent that has the same age and has the same layers as a rock on a completely different continent. Like these two rocks here. Oh, you mean this rock and this rock? Yeah, they're the same age, but they're technically minerals. It's like rock, minerals, things. This rock is the same age and has the same layers as this rock, but they're from completely different continents. This one's from Africa and this one's from South America. Next up on our evidence list is continental fit, aka, or what most people call it, is continents look like they fit together like puzzle pieces. No, Daddy. Like in this demonstration. See, South America and Africa, and these are other two continents. And, as seen right here, they go together. The next topic is seafloor spreading. The theory was formed by Harry Hess after he realized with a special mechanism that there were deep trenches and ridges in the ocean, which had very high heat readings. And then he figured them out. The ridges in the ocean were mid-ocean ridges, and the trenches in the ocean were deep ocean trenches. And what seafloor spreading is, it happens at diverging boundaries, meaning as those boundaries are pulling apart, new crust is coming up and forming at mid-ocean ridges. And at deep ocean trenches, it can also have subduction happening, which is when old crust is being sucked in back into the mantle to be recycled. At deep ocean trenches, old crust is being sucked back down into it and being recycled into new crust that eventually comes out through the mid-ocean ridge, and over probably millions of years, the cycle just keeps repeating. It comes out through the mid-ocean ridge and it goes back in through the deep ocean trench, as seen in the model here. The next segment of seafloor spreading is the age of rocks. The farther away from the trench, the older the rock. For instance, this rock. This rock is, I think, 2 million years old. I'm probably wrong. It's probably just a normal rock that's like only 1 million. But this is an old rock, and it was found very far away from the mid-ocean ridge. This rock, on the other hand, was found very, very close to the ridge, meaning it's only about probably 500 years old. See my point there? Farther away from the ridge, the older the rock. The closer to the ridge, the younger the rock. Now, for the final segment of seafloor spreading, I will explain to you how a mid-ocean ridge works. Convection currents in the mantle, which are currents in the mantle that flow the magma around and around. So when the currents come up, they push just a little magma out, and then they come back around, and then they do it again and again and again. And that magma slowly oozes out of the mid-ocean ridge, very fastly hardens, and then it starts all over again. But here's the thing. They also happen at divergent boundaries, but you would think they would happen at convergent boundaries, because convergent boundaries are where volcanoes happen. But mid-ocean ridges are sort of like volcanoes. They have magma that slowly oozes out. But in mid-ocean ridges, they fastly cool into giant rocks so slowly that no human could ever see it unless it's over the course of millions of years. And this, the more the magma pushes out and cools, it slowly pushes away the neighboring plates, causing seafloor spreading. The final piece of evidence for continental drift is glacial evidence. I don't know how to say it, Mia. Striations. Oh, okay. Striations indicated that glaciers were present millions of years ago on continents like South America and Africa and Australia. As seen in the model next, which is South America, you will see striations in brown. Bye everybody, thanks for your time. Please like and subscribe. Seafloor spreading and continental drift together formed what is now called plate tectonics. Plate tectonics is the interaction of Earth's rigid lithospheric plates as they slide slowly over the asthenosphere. What this entire video is talking about is why plate tectonics exist. Mid-ocean ridges, deep ocean trenches, stuff like that. And so, that's it, and Mia had to go home.